Hello everyone, this is Niharika from Sri Venkateswara College of Engineering. I am back with my new video and I am from CSE Data Science student and here is my topic Integral Calculus and this is the content. Foundation of Integral Calculus, Applications of First Order Integrals, Applications of Second Order Integrals, Applications of Third Order Integrals. Let us see one by one in order. Let us see the foundation of integral calculus. First of all, what is calculus? Calculus is a branch of mathematics that deals with rate of change and slope of curves. The basic of this integral calculus deals with the accumulation of quantities such as areas, volumes and masses by means of integrals. Fundamental theorem of calculus. The fundamental theorem of calculus establishes the relationship between the integrals and the differentiation. Let us see the first order integrals. Applications of first order integrals. Let us learn where these applications has been used. First order integrals or integrals of first order differential equations have a wide range of applications in various fields. Here are some examples. In physics field, exponential decay and growth. Many physical purposes exhibit exponential decay or growth. First order integrals are used to model radioactive decay, population growth and charging or discharging of electrical circuits. Let us see in the biology field. Drug absorption. Pharmacokinetics involves the study of how drugs are absorbed, distributed, metabolized, and excreted by the body. First order integrals helps in the determining how the concentration of a drug in the body changes over time. In economics, compound interest. Compound interest calculation involves the exponential growth. First order integrals helps in understanding the accumulation of wealth over time through investments or loans. In chemistry field, reaction kinetics. Chemical reaction often follow first order kinetics, where the first order kinetics is the rate of reaction of is proportional to the concentration of one reactant. Integrals of this reaction provide insights into reaction rates and concentration over time. Let us see in engineering field. In cooling and heating process, Newton's law of cooling and the heating of objects involves first order differential equations. These equations describe how the temperature of an object changes as it loses or gains heat to or from its surroundings. In environmental science, in radioactive decay in nature, understanding the decay of radioactive isotopes in the environment is crucial for environmental monitoring and radiometric dating. First order integrals helps to determine the age of archaeological or geological samples. In medical field, in medicine, blood alcohol concentration. When a person consumes alcohol, their blood alcohol concentration decreases over time due to metabolism. First order integrals can be used to model this process and estimate how long it takes for alcohol to clear from the bloodstream. And the second order integrals, here are some applications for the second order integrals. In area calculation, double integrals can be used to find the area of a two-dimensional region in space, which is particularly useful in geometry and calculus. Let us see how the second order integral used in volume calculation. When dealing with three-dimensional objects, double integration helps to calculate the volume of regions between surfaces and mass and center of mass. Second order integrals can determine the mass of an object with non-uniform density and locate its center of mass. Moments of inertia. Double integrals are used to calculate moments of inertia, which describe an object's resistance to rotation. This is important in mechanics and engineering. And let us see in the probability density functions. In probability theory, double integrals help to compute the probabilities for events including two random variables. In electric and gravitational potential. In physics, double integrals are used to find the electric potential and gravitational potential due to distribution of charges or masses. As we learned that first order integrals and second order integrals has been used in various fields, let us move on to the third order integrals. Applications of third order integrals, also known as the triple integral, extend the concept of integration to three-dimensional space. They have several applications in various fields. Volume calculation. Triple integrals are primarily used to calculate volumes of three-dimensional regions, particularly irregular shapes or regions defined by the multiple equations. Mass and center of mass. Similarly to second order integrals, triple integrals can help to determine the mass of three-dimensional objects with varying density and locate their center of mass. Moment of inertia. Triple integrals extend the calculation of moments of inertia to three-dimensional objects, which is important for analyzing the rotational behavior in space. Electric and magnetic fields. In electromagnetism, triple integrals are used to calculate the electric and magnetic fields generated by charge or current distribution in three dimensions. Probability density function. In probability theory, involves three random variables. Triple integrals can be used to compute the probabilities for specific events. In triple integrals in physics, they are used to calculate the quantities like the total energy, momentum, angular momentum, and quantum mechanical expectations values for three-dimensional systems. In fluid dynamics, triple integrals can help to analyze the complex three-dimensional flow patterns and calculate the properties like flow rate and pressure. In heat transfer, for three-dimensional heat conduction problems, triple integrals can be employed to analyze the heat flow within solid objects. As we learned all these three orders of first integration, second and third integration, we learned their applications and that how it is used in our day-to-day lives. Thank you for watching my video.